Now we are going to start with a magnetic field. As I told you that whenever suppose I have a magnet like this, right, so around a magnet a small area is developed where its effect can be felt, and that is called as magnetic field. So magnetic field is a small area around magnet where its effect can be felt actually. This is what is the magnetic field. Now as you cannot see the area around, as it is an imaginary area, although the area is already present, but you cannot see that to how much extent. Suppose I have a magnet, I cannot say that magnetic field is still here, I cannot say magnetic field is still here. So it is all you can say we cannot see that. But in order to understand what we consider, in order to study magnetic field, we consider hypothetical lines. We consider hypothetical lines called as magnetic lines of forces. Called as magnetic lines of forces. We just consider these lines in order to understand magnetic field properly. So I am just trying to tell you about the characteristics of the magnetic line. You know that if you want to see those magnetic lines, how we can actually know that? Suppose let's take a sheet of paper, you can do it. Let's take a sheet of paper, sprinkle iron fillings on it, sprinkle iron fillings on it like this. Now what happened? Now just place this paper on the wooden board. Let's say this is the wooden board and I have just pinned this paper. Let's pin this paper on the wooden board. Now like below the paper, what happened? You just move, keep the bar magnet. Suppose again I am telling you, I took a paper, there was iron filling sprinkle over it, I just put the bar magnet below it. Then when I put the bar magnet below it, I saw that they acquire a proper shape, they acquire a particular shape. So their shape was something like this. I'll just tell you. Suppose let's say that below it the bar magnet is like this. So the shape was actually like this. They were arranged like this. They acquired a particular shape. Then when it acquired a particular shape, I just pinned this paper on the wooden board. So this you can see actually. So in order to study that, as we cannot see that, but we can feel its effect as the iron fillings got arranged in a particular shape. So we consider the imaginary lines, that is magnetic lines of forces. So if somebody asks you to draw the the magnetic lines for the magnetic field, how you are going to draw? See, bar magnet is like this. So in order to understand how we are going to draw it, we are going, suppose this is North Pole and this is South Pole. So they will start from North Pole and they will terminate at South Pole. They start at North Pole and they terminate at South Pole, these lines. And similarly below it also, it starts from north and terminate at south. So like this we can draw many lines, just indicating that these are the lines that are going from north to south. Likewise I can draw more downward also. So as there is a small space, so what I can do is I can just show the half lines. It is understood that they are going towards the south, and here also I can show many lines just indicating that they are going towards the entering the south. So this is how you are going to draw the magnetic lines for the bar magnet. Now moving on to the characteristics of the magnetic line, that what are the magnetic lines characteristics. First of all, I told you that they are hypothetical lines. They are hypothetical, that means they are imaginary lines. And moreover, we see that they originate from north, they always originate from north and terminate at south. They originate from north and terminate at south. We have also seen that what does this magnetic lines actually try to give us. It tries to give the information about the magnetic force. It gives the information about the magnetic force. And moreover, if I want to see a magnetic force direction at any point, let's say if I want to see the magnetic force direction at this point, so what I'm going to do is I'm going to draw a tangent to it. The pointer of the tangent, the direction of force is that which the pointer of the tangent points towards. So that means we can get the direction of force at any point by drawing tangent to that point, We cannot know the direction of this. Suppose I need to find the direction of magnetic force at this point, so I'll draw the tangent like this. So that means it is pointing towards it is showing the direction of the force. And moreover, we have seen that if we talk about these lines, they are closed, continuous curves. They are closed continuous curves. And moreover, we have seen that two magnetic lines never cut each other or intersect each other. Two magnetic lines never intersect each other. You know that what is the reason behind? See, they are giving the direction of force. So if they will intersect, let's say they intersect like this. So can they intersect? No, because they are giving the direction of force. So and at the same time, force cannot have two directions because force is a vector quantity. So that means they don't intersect. And moreover, the area where these lines are close to each other indicates strong magnetism. So as you can see that they are closer towards the poles. So that means strong magnetism is there at poles, and they are far apart in the middle. So there is the least. So that means the area where they are closer indicates strong magnetism, that is poles, and area where they are far from each other, that indicates the weak magnetism. So these are the characteristics of the magnetic lines of forces. So I think you got it. So magnetic field is a small area around the magnet where you can feel its effect, but we cannot see it. So therefore, we study about magnetic lines of forces. How they look like or what are the characteristics? They are hypothetical. They are closed continuous curves. Right? They originate from north and terminate at south, and they give information about magnetic force. And if you want to see the direction of force at any point, how can you see that? Just drawing the tangent. Likewise, two lines never intersect because they give the direction of force, and force can never have two directions as it is a vector quantity. And area where they are closer indicate the strong magnetism, and that is the poles. So these are actually the magnetic lines of forces. And if practically you want to prove that, I told you, take a sheet of paper, sprinkle iron fillings, just below the paper keep the bar magnet. You will see that they will arrange themselves in a particular form. This actually confirms that in the magnetic line in the magnetic field we can actually study about the imaginary lines, that is the magnetic lines. So this is the practical experiment you can draw, and your teacher may ask in school to do this. So this is so simple, you have to do like this. So this is what is the magnetic lines. Now, as if we talk about, if I ask you, or if it is being asked that why magnetic lines always originate from north and why it always terminate at south. So it is an assumption, it is not a correct answer, it is just assumed that it actually shows that if north is free to move, if north can move, it will move towards south due to attraction. So this just indicates that is why it originates from north and terminate at south. And this we have already discussed, that two lines never intersect, right? And you know that there are, as I told you, that in earth there is in the core of the earth there is a lodestone or a magnet is present which can attract certain substances towards itself. So that means earth itself behave as a magnet. That is why it is attracting all substances towards itself. And you know that if you talk about the evidence from which we came to know that earth also behave as a magnet, is that like when a freely suspended magnet, suppose you suspend a magnet by thread, so I told you that freely suspended magnet always align in north-south direction. So why it's so? again the answer is just an assumption. It is that suppose the magnet always align in north south direction, just because that in the core of earth the natural magnet which is present, it is present in south north direction, and due to attraction it aligns in the north south. So that means in the core the magnet is in south north direction. So therefore when you freely suspend that magnet on its surface, it is going to align in north south direction, indicating the magnetism. As we all know that like poles repel, so obviously the opposite poles will face each other. So this is what is the magnetism, and this is the evidence in you can say in support of this, that earth behave as a magnet. And moreover, you know that if you will take a iron rod deep, and it has been already done actually. Suppose you take a iron rod and you just bury it inside deep in the earth, and after some time if you will take that rod out, and the rod which you need to take is this soft iron rod. So suppose you take a soft iron rod, and this the scientists did actually, they just buried that rod deep into the earth, and when they took out it it became a magnet actually. So it just proved that earth has a magnet in that area, that is why it has magnetized that soft iron rod. So this is just an evidence that to show that the earth also behave as a magnet. So this is what is the magnetism. I think you got it. So in this chapter what you need to know is that how the magnetism concept came, what is lodestone, what is artificial magnet, what are magnetic lines, how can you show that, how can you prove practically. So this is all you have to do in this chapter, and moreover you should know that what are the evidence in response to a fact that earth behave as a magnet. So this finishes our magnetism.